In this video, I'm going to show you the solution to the recent formative assessment on topic projectile. So start off first question, you have a projectile fired at 12.5 meter per second at 43 degrees to the horizontal on a flat ground. How long does it take to reach the ground? You are looking for the time of flight. So as for this question, I'll be using the common formula, the one formula that I'll be using in the class. And the most critical component of this equation is that you have to get the correct S-void. So remember, when the projectile is reaching the ground, for this case, okay, you are landing such that you will not gain any height. Therefore, my S-void shall be 0. And the U-y is the vertical component of the initial velocity. So initial velocity is 12.5. The vertical component, you have to take the sine of 43 to get the vertical component. And you have to plus half of g minus 9.8 t squared. And how do you solve this? You can factorize the t. This is what you get when you factorize the t. And basically, you're looking for the term inside this bracket to be 0. So when you solve this equation in the bracket to be 0, your time here is equals to 1.74 seconds. Okay, so that's one way of working on it. And I do realize some of you choose alternative. For example, using this alternative, I use a blue color to show the alternative. So you've been telling me that at maximum height your Vy is 0, which is correct. And your Uy is the same, Uy plus half, not half, plus g minus 9.8 t. And what you'll be doing is that you solve this time here, divided by 9.8, and towards the end you take this time here and you multiply by 2, which you will still get the same answer. And it is perfectly fine to do it because in this case the trajectory is symmetrical, so it's fine for you to do this. So this is also acceptable. So yeah, so we have two ways of working, up to you to choose the proper one. Okay, I will move on to the next question. What will be the maximum height does it reach? Maximum height, I have my common formula. This would be my formula again. Okay, and maximum height, I do know my Vy must be 0. And my Uy is 12.5 sine of 43. Don't forget this term is square, plus 2 of g. And this is my Sy. I forget the Sy here. And my Sy here is 3.71 meter. It's about this value. Alright, and some of you also choose to do the alternative by using this equation instead. Okay, half of gt squared. This is perfectly fine. Alright, I will show you how do you use this alternative. Your Uy is the same. And what do you substitute the t? That is the main question. Since this trajectory is symmetrical, maximum height occur at the half time. So if the total time of flight is 1.74, at maximum height, the time here shall be 1.74 divided by 2. That will be the time at exactly the maximum height. So this shall be your t. Okay, and plus half of g, negative 9.8, and followed by the same term, 1.74 divided by 2, because this is time at maximum height. Then don't forget to square. Believe me, you will get exactly the same answer. Okay, this is also acceptable. I will move on. How about the horizontal distance does it travel when it strikes the ground? So apparently for this case, you only have one formula. There's no other alternative. Say, and what's your ux? It's 12.5. Okay, this is horizontal component. Now you're using cosine of 43. Time of flight 1.74. 15.9 meter. That is the answer and is the only working way. There is no other alternative. And lastly, what velocity does it strike the ground? Show your full working. Velocity is a vector, give me the magnitude, give me the direction. One thing I know for sure is that when it strikes the ground, my Vx tentatively would be 12.5. Okay, it's difficult to write for cosine 43. That is for sure. You need to determine your Vy. This one you have to find out. Okay, how do I find out? Apparently, this is the equation that perhaps the fastest. Uy is 12.5, sine of 43 plus g is negative 9.8, followed by, at the end of the time of flight, it happened at 1.74 seconds. So my time here, sorry, my velocity here, my Vy, is a negative number, which is a good thing for this case. What you need to do, find the velocity by using Pythagoras theorem. Okay, so I leave it for you to do it yourself, and this is about 12.5 meter per second. And how about the angle? The angle here I can find by using a tangent, my inverse tangent of the Vy over Vx. Okay, so please substitute the Vy value and the Vx value, and you shall have this answer, 43.0 degree. And this presence of a negative, as I mentioned in class, will tell you that it is below horizontal. So that's it. Magnitude and the direction 43 is below horizontal. Please remember that. So that's the answer for the first question. Thank you.